Hi all, this is the MakeHaven video for the cutoff saw. Smaller version of a saw that we'll probably have in the future. This is called an abrasive cutoff saw specifically, so similar to an angle grinder, it has an abrasive cutoff wheel. So it doesn't have teeth that it's using to cut through a piece of material. It's just an abrasive material that grinds through it, and it's thin. So the idea is it's cutting as opposed to necessarily grinding and shaping. It's pretty small. It's effectively like a small angle grinder just mounted on the bench, but because it's small, it can be pretty mobile. So if you have a longer piece, you're welcome to unclamp it and move it to a bigger table where you'll have more working room. And it is, similar to an angle grinder, fairly dangerous. So the biggest risk with it is this disc exploding. It's spinning very fast at 9,000 RPM, so really fast, and if it explodes, it's going to shoot outwards. And so that's why we're wearing the safety vest and a face shield. And so this is obviously protecting your vital organs, and then this is protecting your face, and it's in addition to these glasses. So right now, for example, I've lifted the shield up, but I still want to have my glasses on in case there's someone else working and the wire wheel is going and a piece of metal comes off of it. So that's why you have glasses and the face shield. This machine does have a little guard that helps to protect you from the wheel, and it raises up as you go down. However, that is not a substitute for the face shield. So that explains these two pieces of PPE. In terms of things that you can cut on it, this tool is just for ferrous materials. That means things that have iron, which pretty much means steel. So stainless steel, mild steel, hard steel, carbon steel, steel. If you try to cut something like aluminum, the aluminum will just melt and get into the abrasive wheel and readily destroy it. Same thing with a bench grinder wheel, just for steel. So I've picked up 3 pieces of metal. This is galvanized steel, which is not great, but if you're just doing a quick cut, probably not the end of the world. Piece of flat stock, piece of square stock, piece of round stock, and technically this is square too, round stock. So this is a pretty simple tool. It has a clamp in the front to hold the material. You want to make sure that the material is well clamped so it is not going anywhere. And you just spin this outwards to open it up. You can adjust the angle, so you just get 2 Allen keys and get them here, and then adjust the angle. If you want to make sure that your piece is really square, I would recommend getting a square and putting it in here against the blade to make sure that the piece is in fact totally down. When you're making adjustments like that and your fingers are underneath the tool, you want to make sure to unplug the tool from the wall. What we're going to do is I'm just going to spin this back enough so that we can take this piece of square stock and just get a vague sense for how square our blade is. Okay, so we're going to bring it down, and it looks like it's sitting pretty flat against the blade. So I think this is relatively square. That's not the best way of doing it. You would take an actual engineering metal square and square it up. This blade's also pretty small, so it's not cutting over that big of an area. Now, to that point, the things that we're cutting on this are steel, and then in terms of shapes and sizes, it needs to be pretty small. So this is too big for a bunch of reasons. One, I'm not even sure the blade could go all the way through it, so immediately disqualified. But even if it could, you don't want to be cutting something that deep on the blade. Because once you're that deep on the blade, any twisting or torquing is applying a whole lot of movement to that blade, and it's biting on all sides of it. You really want to be using the edge of the blade to be doing the cutting. And once you're that deep, then the sides are hitting the metal, so that's not a great situation. So this size tool is going to be better for flat stock, round stock if it's well secured. Something angled is okay, again, if it's well secured, but you don't want it going too high. For something like this, you would use a bandsaw, and that would be the right tool. Getting a bandsaw set up for something quick though, where it could just be a chop, would be might be more time intensive than using this tool. So that's the calculation you might use. Again, if it was aluminum, you would not use this. Something like aluminum, you would cut on the bandsaw or the hacksaw, not with an abrasive wheel. So when you're going to use the tool, you just want to give it a quick look. I'm going to unplug it just so we can look at the wheel itself. So I'm just looking to see if there are any big chunks missing from it. If it's cracked, obviously, that would be an immediate disqualifier. It looks pretty fine to me. And so I think we're good to go. If it was getting too worn down, so this is an abrasive wheel that just progressively gets smaller and smaller as it's worn down, then you could replace it. So now we're going to look at the materials we have here. We already covered these raw steels. This is a piece of galvanized steel, which means it has a zinc coating. If you were trying to weld it, that would be a no-no because it would vaporize the zinc and produce, that would be very dangerous. Grinding doesn't get to that temperature. However, if you were to be cutting a bunch of it, wearing a respirator would probably be a good idea just because you don't know exactly what's in the galvanization and you don't necessarily want to be breathing that in. I would say actually in general, if you're doing any large amount of cutting of any steel, wearing a respirator is a good idea. If you're doing one quick cut, you're probably good to go, but say for more than 2 minutes, you should probably put a respirator on to make sure that your lungs are protected. Then we have these other pieces. This one we said was too large. This one is cylindrical, so we need to make sure that it's really well clamped. So now we're going to talk about cutting. You want to make sure that you're standing out of the way. You want to make sure that your workpiece is supported. So in this case, if it falls a half an inch onto the table, that's fine. If we had it in a situation where it's much longer and hanging off, you'd want to make sure to have piece supports so it didn't fall on the floor. You definitely don't want to be surprised or scare anyone else. When the piece has been cut, it'll be quite hot, so you want to make sure that you are handling it with pliers. And sometimes it's a good idea out of a metal can of water that you can dunk the pieces in when you're done so that they cool off and are safe to touch. Bear in mind that by quenching a piece of metal, that can change its properties. It could effectively harden it. So in some cases, you just want to let the metal cool normally. So we're just going to cut this piece. It's a piece of square stock, and so it'll be held firmly. We'll go over some clamping techniques. So for this piece, we're just going to tighten it in. Unfortunately, this is slow. And then this piece just articulates to match the material that you're cutting. And in this case, we'll see if it gets a good firm clamp. And it seems to be pretty good. Sometimes it'll be wobbly or not good, and part of that might be that it's bending over. And so what you can do is take another piece. So if you had another piece of this metal, then we could put it up by the top, and that'll make sure that this stays parallel and doesn't bend up or down. For a piece of cylindrical stock, you might want to do the same thing depending on how well it clamped. You could also use your left hand to hold on to it to make sure that it is well secured, but you want to make sure that the clamp is doing 99% of it. You certainly don't want to rely on your hand to prevent this from spinning. If there's any risk of this coming loose and spinning, then you should find another way of cutting this. So we're just going to clamp down on this. We would, if we were making a precision cut, and I'll cut off this end because this looks less useful, then you want to have a mark. And remember that this abrasive wheel is going to remove material. It has a kerf, a thickness of cut. So if we wanted to keep this piece, we would cut on the right side of our line. It's kind of hard to see, but it's coming down here and cutting the material. So I'm just going to clamp down on this. It's firmly on there. This saw is clamped down to the table. And now I'm going to move to this side, so easy to see from that side. Again, I'm standing out of the way, so if this were to break, it's not going to go into me. I'm still wearing this. I'm going to put the face shield down, reach over. And it looks like it didn't actually cut all the way through. So this must have hit something when it came down. Yeah, so this is hitting the rest. So I think what's happened is this blade has been used so much that it has shrunk in diameter to the point where it isn't cutting all the way through. So that means that it's time for this blade to be replaced, and that's something that staff will do. However, that doesn't really change the principle of it. This piece of metal is still very hot. It would have fallen through. Two other points are, one, hearing protection is a good idea, especially if you're doing more than just one quick cut. This can be very loud. So you can wear hearing protection and the mask. So that's not a concern. Another is that if at any point you aren't seeing sparks, that means that you're cutting a non-ferrous material. So if you aren't seeing sparks, that's a good indicator to stop what you're doing and check to make sure that you're cutting a steel or iron. Because again, if you're not, then that's a big no-no. So when you're done, you're just gonna loosen this. You can see there's actually some discoloration from the heat, which is probably still quite hot. So I'm just gonna let that cool. We could also just grab some pliers to pick the material up with, because it is probably pretty hot still. And if we wanted, we could have a metal can that we dunk it into, or we can just leave it on there, making sure that no one else is likely to come over and touch it. It's a big chunk of metal, so it's likely to stay hot for a little bit. And then you're good to go. So we'll make sure to replace this blade so it's big enough to cut through pieces, and hopefully in the not too distant future we'll have an even bigger version of this so that you can make bigger cuts. Thanks for watching.